Hello and welcome. I am continuing on today with the design of a computer. This is a CPU card which will connect to a BME bus backplane with additional cards and additional CPU cards as well. So just to recap, this is the 68030 CPU, some memory, some RAM, some flash, complex programmable logic device to glue these all together, some transceiver chips for the bus, serial port controller here, and two FTDI USB to serial port converters here, as well as some LEDs and push buttons, which are reset push button and some user-definable push buttons and user-definable LEDs, which are controlled by this serial port controller, which has some general-purpose IOs. So most of everything is connected here. On the actual computer part of it, it's these LEDs and USB to serial FTDIs that need to be connected now, and that'll be the end of it. Hopefully, we're getting pretty close to the end. I am using a different audio filter. I wanted some of the clicks and keyboard presses to come in, but it might be more disruptive. Let me know if you have a preference. Today's mix is posted in chat. It is from Dopo Goto, Go-To. PlayStation 2 era ambient jungle D&B 2-hour mix, if you would like to listen along. I'm not mixing the audio into the stream, just so that you have the choice of listening to whatever you'd like. It's more of a chill mix. It's just nice, chill Sunday afternoon. All right, let's dig into it. And the first thing I notice is that I kind of don't want that there. I want this to be more centered. It's okay to be there. This dashed line here is the clearance for the card slot. There's a plastic card guide on the top and bottom of the card as it slides into the Eurocard standard slot. So traces can be in this area and silkscreen can be in that area, but chips will, or parts will interfere and prevent the card from inserting correctly. So move that over. It's a little more center. It looks nicer than being off center. I was going to rotate some of these resistors and capacitors. I don't know if I should like keep a consistent pattern of having all the grounds on this side, which would mean rotating these three chips here to make them match, and then rotating this one so that the 5 volts are always on that side, just to make it a little harder to accidentally short a pin between ground and 5 volts if they were like right next to each other. Not that that would be a common thing, but I anticipate some difficulty with bringing the board up, just because there always is difficulty. There's always a need to fix mistakes, and there's always mistakes. Yeah, let's just keep it consistent there. So we're going to rotate all 4 of these top ones. And I might as well just unroot these while I'm here. And then we'll move the labels around, again, just for consistency. All right, there we go. We'll just, oh, we got a little bit of a trace there. Status LED. Again, doesn't really matter, but just increasing the clearance there a little bit. All right. We can change to our thicker trace here and just put in the vias. These are surface mount resistors and capacitors, and we have a 4-layer board with 2 internal planes. If I just turn the copper pores on, you can see, I will recalculate them. So the red layer is on the top of the board, the front of the board, which is the same layer as the components. The green layer is our 5-volt power. The orange layer is our ground, and the blue layer is also signals, which also has a ground plane connected to ground. So whenever you put a hole through the board, including vias, they will be able to connect to whatever layer they need to. So if it's a ground, it'll connect to the orange ground layer. If it's a 5-volt, it'll connect to the green 5-volt layer. And so that's how we can get power to these pins. These ones, because they are connected to the top ground plane, they are actually all connected, and you can see that with these thermal resistant spokes coming off them. or thermal relief. So technically, this one is already connected to ground, so you're not seeing the white rat line that indicates that it is not connected. But might as well just put vias on all of them. Get some good connection instead of relying entirely on the ground plane. Ultimately, it's got to connect to the ground pins over here on the back plane, which is the primary source of power. And then the 5 volt is coming off of here on the bottom of the connector. So way over here, you've got to have a solid connection. And if it's able to just jump onto the ground plane and go straight across the board, virtually uninterrupted, interrupted only by the through-hole chips, then you have a nicer, solid connection to ground. So I'm just going to keep doing that. Putting vias on all of the pins, and since I'm doing that, I might as well also line them all up so that they're nice and aligned. Couple more here. I'm going to switch back to a thinner trace for signals. Those ones are easy enough to connect. I like them coming out straight instead of on an angle. It makes it a little stronger because the copper is, yeah, not that it's going to be an issue here, but I have actually on previous designs had to lift up and replace some of these small logic chips, and have damaged traces in the process, and then had to patch them up with solder. So it is something to think about. Surprisingly, this is going quite easily so far. And go up that way. No, don't do that. Now that I've done that, I'm actually second guessing again. And I think I'm going to just go that way. Because it's a little more direct. We don't go straight, we go direct. There is a difference. Thank you very much. Oh, we got these ones as well. Okay, so that one's gonna go there, that one's gonna go there. Okay. I'm kind of more concerned about that one. Why is it doing that? We'll go onto there, and then we can switch sides. All right, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 signals left. And they all just need to go down somewhere. Let's see if we can compress these a little bit. And then we would have some space for some traces to come down this way. Well, This is the tricky part. These last few ones, I don't know. I don't know. Should I route them from the other direction? Get a better sense of what the best path would be. That needs to go to the bottom one, that needs to go to the bottom one, that needs to go to the bottom one, that goes to the top one, that goes to the bottom one. That's the top one, that's the top one. That is not a thing, that is the top one. So most of the traces, except for this one, go to the top one, and most of the traces on this side go to the bottom one. They will go here, won't they? That one. So I could route these down and have them go in this direction, and then route these ones down in this space. And yes, they're crossing, but we should be able to resolve that without a problem. But that would mean then making a bit of space here. So we can see how viable this is. It's kind of working. Okay. That should be enough space for these signals to come down. And we would like them to come through that. I'll just put them there for now. I will probably need to cross some of them. If I can save a via, it would be good. Oh, stop doing that. If I can save a via, it would be good, but you see that one needs to go down, which means I'm going to need to do vias on those ones. but that's okay. Put it there. And the one remaining is this one. Not really fond of that, if I'm honest, but well, gotta go that way. And then these ones we can come on the outside, but we want the, yeah, this one, the lower one first. Chuck it down there somewhere. And then this is the last one. Okay, I want these to be a little offset from their center. I generally do try and avoid having a lot of, given that the blue traces are going vertically and the red traces are going horizontally, keeping to that as much as possible is good. But whenever we have it on an angle, we're kind of violating that convention. Suppose we could just do that. Probably not good for crosstalk, but I can expand them later. I'm going to expand them now. better. So they've got some good distance now. Welcome, Helena Handbasket. Okay, let's just check this at the top. I think we've gotten all these connections. I think we've gotten all of these connections. I think we're just left with this section here. I see rad lines going to 5 volts, so we don't have our power. Let's do our power first. Get these in. What are these? I thought they were the bypass caps. C6 and C7? C6 and C7. Ah. So they're kind of a bypass cap, but yeah, not mixing in the music for stream so that people can choose their own music if they want. And yes, mounting holes. These lovely mounting holes. So holy, much mount. All right, we can switch back to our signal trace again. What should I tackle next? I've got diodes, I've got the actual FTDI chips to connect. Got some power up here. Maybe leave those. I do have the actual signal lines coming from the connector here. And they are technically supposed to be differential signals. What is going on here? Oh, right. Okay. So we've got signaling to these two inline resistors, which will then okay, so these ones, oh no, I just hit the wrong one. Okay, I have to click that first. But it doesn't want to do those ones. Okay. Maybe I have to label, it on both sides of these resistors. I don't have space, do I? It's a little tight. Oops. All right. Save that, update. No nets found for those, but that's okay. Those are not connected. So now if we route the, you're still not doing that, are you? Oh, KiCad. Okay. going to move this one here and move the resistor and this other resistor from here to there. And I need to actually switch these two around. Really? There we go. Wow. It's not letting me route the differential pair to there, probably because it's too it's got a cross. I've got this to deal with as well. Don't think that's going to change it though. See, it won't even let me select it there, which is odd. Very odd. Well, it's probably not like hugely important. I will move this up here. The two resistors will move down. And then all of them I'm sure that's going to be a little much. And then we can at least do differential pair signals to there. Oh, and the capacitors need to move around as well. And for this, is it still, yeah, it is still not wanting to allow me to route those as a differential pair. Oh, I don't like that. Leave it like that. And then do the same on this side. I know they're not being routed as a differential pair, but this should be fairly slow speed. This is, what, 12 megabit per second? Not the full 480 USB 2. This should just be the full speed 12 megabit per second. If it was a 480 megabit per second connection, I would probably have like a, well, if it was going straight to a chip that supported it, I guess I would have to like flip the chip around to make it more easier for the differential pair to go into. When I build the boards, I like them all to be like all the chips are facing the right way instead of being upside down. Because I did actually design a board where I flipped a flash chip upside down on the design and thought, oh, I'll remember when it comes to building it, and then I didn't remember and installed the chip the wrong way up because all the silk screen labels were the right way up. And as a result, the chip got so hot that it burnt my finger, which is generally not a good thing. Surprisingly enough, I was able to take that chip off the board and re-solder it the right way up, and it still worked, which was incredibly surprising to me that it would work after having power sent into the wrong pins, but it survived it somehow. I'm just kind of thinking about what to focus on next. Why are these connected? Oh, right. That's basically power. And that's the same for these ones, so I think I should rotate these around. These are the resistors that are for the LEDs, which are like activity LEDs, I think. Now I will flip all the labels around so that they're consistent. Where are the other ones here? Is it this one? Okay. Just trying to do them the same, given that they're the same circuit. More or less the same circuit. All right. There's gonna be this one. Right, and this one has power. Which we can do to here, but we actually want a bigger via because it is power. And then we can go to the back side of the board onto there. I only have the power option on USB 1, not on USB 2. Why are these different? Oh no, oh no. Have I wired these wrong? Yeah. These two are not the same. But which one is correct? Now I've got to look at an old design. I know that this board probably had the correct pinout. DTR was pin 1. Let's check this board. DTR was pin 1. And then for this board, I think I had them like backwards to what I expected. DTR is still 1, okay. It was maybe that other one. This is the one where I had it. The flash chip was upside down. This was the flash chip. DTR is still pin 1. But it's the bottom. And for this one, I'm pretty sure it was DTR's the bottom. There was one board I remember I had where the actual FTDI thing, like I have some separate boards that I can put on. And it was facing into the board instead of out of the board. Mirror vertically. All right. So like that. So DTR is pin 1. Let me check these boards that I have. These are the boards. to change the connector on it so that it would fit onto the board. Let's see, this is old design. So DTR pin 1, and I can't for the life of me see this. DTR is that pin, so it does actually fit on like that. Right, so DTR is pin 1. DTR should be facing downward. Let me double check that one last time. These were the ones that had the sideways, and pin 1 is down. Yeah. It's a little confusing, but just set that aside for now. Back to this view. Okay, so these are correct, and I need to update those pins. Okay, those are, well, they're saying it wrong. Pin 1 DTR should be downward. Oh, okay. I'm going to, don't want to delete that, but I do want to unroot these. I might as well unroot all of them. I was a little confused by that. I was like, why is it why is it that those pins and these pins were a little different? Well, that explains it. And we want pin 1 DTR to be the lower pin. Just using a line here as a mark so that I can align it the way that I would like it to be, right there. Like that, and then we can delete that line. And these ones, make those closer. Hey, the Bit Welder. Welcome. I'm doing pretty good, thanks. Hope you enjoy. I'm sorting out the last little bits of these FTDIs. So this is just as like an extra, just in case I would like to bypass the onboard FTDI. I've got some header pins. And I've got like separate little boards that I can plug in to those, or a cable that I can plug in to bypass it. But I just noticed that they were backwards, and if they were in the pattern before, the actual board would have been hanging into the board this way instead of over top of these the actual onboard FTDIs. So now we've got that sorted. We can reconnect the various things that we had previously connected. These are going to be going to different pins now. That should be good. Now it goes up there. And this one goes all the way down. We can just put it straight in. But we're going to need a via on that one, right? Ah, perfect. Okay. That one can go there. We'll get that one. We'll get those ones later. Okay. Moving back to this one. That will connect there. This one will go down to the bottom. We can just go straight in. Doesn't quite look right there, but all right. There we go. We're almost done. We've just got these 3 signals on both chips to route to the pins, and then we're done. But what way do we go? That one could go up and the other ones want to go down, and that's going to cause us some problems, isn't it? Maybe before I get too far ahead of myself. Okay, we can go out to here because we want some space here. And then we'll go back onto the front side of the board. We might even want to do that. That one and that one. Crossing over each other. I think I'll go that way. Get onto the back side of the board. we'll go up to here and then through there. Do the same on this board or in this FTDI. Oh, it was that one, right? And it's just coming on the other side for that one. I was just confused by the fact that it's a little different going into the CTS pin on that one versus the other one, but that's just because the connector to the controller is on the other side of the this connector. Okay, backside and that. And oops, I did not want to do that. Let's make some space here. Wow. I think we might have all of the connections. What does the checker say? 38 errors that are mostly silkscreen. VIA is only connected on one area or one layer. Crap. What one was this? Where did you take me to? There you go. Ooh. Oh, wow. Okay, that is actually a mistake. There we go. It was saying it was only, the VIA was only connected on one layer. It was supposed to be connected, but it wasn't. I also noticed that there is a connection there that should not be there. And that is really fucking tight. Oh. I could move this via and squeeze these down, or I could try and move the capacitor up a bit, but it's then going to interfere with these other vias. Are these? Ooh, oh, wait a minute. I thought I had changed those. Okay, let's go back here. Back to the schematic. C25 through to C29. I thought I had changed the footprint sizes for those. C25 5 through C29, yeah. It's, I had changed them to this one, so I guess it didn't get updated. Save. Save. Update. There we go. There we go. Okay, that looks better. So I had used a smaller capacitor on these ones. I've only ever used the 0805s, never the 0603s, and I was a little afraid to use the 603s, but I also needed space here because it's just so tight. So we'll see. I was only going to make these ones be 603s because I need the space there, whereas the other places I can afford space, so leave them as the easier to solder 0805s. And for some reason, I forgot to add the connection there. Okay, we'll do design rules again. It's mostly like silkscreen overlapping, which I'm not really concerned about right now. Why is it? Oh, there we go. Tracks crossing. Oh. How did I manage that? Thermal relief connection incomplete. All right, let's turn on the layers. I mean, that's not a problem because I'm connecting it to ground. Okay. These are problems, though. Well, that is actually a problem of the connector, the footprint that I'm using. I don't think I'm going to be able to solve that one because that's just the way the connector is. So that's that as well. So those first ones, that's that one as well. Item shorting two nets. I think I'll leave that for another day for figuring out. These are all related to the USB connectors, the USB-C connectors that I'm using, and some silkscreen ones, which I'll come back to later, and then these ones. Drill hole too close. So that's, those two are too close. And those two are too close. Where were we? Silkscreen warnings, then these ones. Okay. All right, those ones are handled. Again, we're still leaving the silkscreen ones. About halfway through. Okay. That's probably fine. Thermal relief issues. Is that enough to fix it? I don't know. 28. Okay, that seemed to fix it. Another one. All right, let's turn off those first to see what we're dealing with. So we could put a tiny little via right there. This is a 5-volt. All right. So this is like the copper pour. It's unconnected on this layer. And even though it is going through the board, is that even connected? Because there is no... Oh, right. We have the 5 volts here. So we've got 5 volts on the top layer coming through. I'm actually going to put another trace there on the 5-volt line. Not only will the via suppress the air, but well, actually, why don't we, since we did that, put the via there. That should handle the complaints. Now it's complaining that the bottom layer is unconnected. We do have a actual dedicated ground going through there, but I can throw another little via in there. And now this is complaining about thermal relief. Why aren't you connecting it? You could connect it. You're not connecting it. We actually do have a ground, so I'll put it there. That should still at least connect that. Got a lot of these errors. It's mostly on the CPU too. Okay, what are we dealing with? There. Okay, I'll just run the design checks again, see where we're at. We have a warning now. Okay. 2 steps forward, 1 step back. Skipping over those ones. We're back into thermal relief. All the rest of them are. Oh, there's some other ones as well. Okay. But a lot of thermal relief complaints. I'll have that come out like that, and then I'll put that on. Is that going to actually fix the error? 24? 24? Yeah, 24. Okay. So that's fixing it. That one I don't know about. That one I don't know about. This one. I'm going to leave that one. I keep pressing that bottom one. Stick that there. That doesn't have one, but this one does. know why that one's incomplete. Is that, well, I'll rechen. Those ones are complaining about, yeah. All right, we'll see where we are. 21 errors. Yeah, the view is only connected on one layer. It would have to be the front side if I wanted to. And it just doesn't have a connection, I guess. So I'm just doubling up the connection just because it's a power connector. It'll be drawing lots of power, so. Do I have any connections to that? I do not. Okay, let me just step back a bit. I have connected all of the grounds together here, but I haven't explicitly connected the power pins together on the power layer. And I figure I probably should, just to make sure that I've got good power to the CPU. No, don't do that. All right. Probably didn't fix anything, but I'm gonna try tackling some of those silkscreen warnings. Clipped by board edge. Now that makes me wonder if I've accounted for that. I did actually use, it was on this switch. I have actually used that switch on another design before. So let me just pull that up. I had it hanging over the board edge. And that is the board that I have not, I don't have a front panel for it. The intention was to, this this extra box in front was intended to be the an aluminum or PCB front panel cutout with holes for the lights and space for the push buttons. The push button I have does not have very deep like stems. I wonder if I can even get one with longer stems, because that's probably not going to fit through. The stems are coming out to about the end of the LED here, with this design, with it hanging over a little bit, and this design, I have it a little further back. But it's like right at the edge of the board. I don't think I want to move it any closer, any further out. It would be. I think I'm gonna leave it at this. So I'm just gonna ignore those warnings. Okay, where were we? So it's warning about that one. I'm going to leave those ones. Those ones I'm going to leave. That is also those. That is also those. That is also those. That is also those. Thermal relief issues. That one didn't get fixed by that. That's the best you get. And those are all issues with the USB. That one didn't get fixed. USB. Okay, here. I'm just going to, or actually, I will put it onto FFab. Don't really need that label, so the FFab layer will not get printed, nothing will appear. So it's still there, but the in and out labels are the ones that matter. Let's run that again. Unconnected. I'm gonna need to explore that footprint at some point. Okay, those are all the ones that I'm ignoring. Oh, I can exclude it. Okay. It's useful to know. I don't want to exclude them yet because I want to see if I can fix them. All right, there's a silkscreen overlapping. It's one that I can fix. That's the last one. Okay, so it should be 20 and 7 now, right? $20 and 6, okay. Or 21 and 6. Right, because those are just warnings. All right. What is this? Yeah, that via just is not helping the issue. I'll leave it off. All right. Let's. There we go. October, November. I mean, it was October and November. I like October better, so I'll leave it as October. It seems like a decent space for it. There we go. I think we're pretty much done. We could view this 3D. Hopefully these are not too much of a problem to hand solder. I'm probably going to have a pain of a time soldering all of these, but just looking at that might be a little tight, but it's doable. I'll maybe check what that distance is. Just looking for anything that like stands out as space-wise. It's kind of easier to see on this. Was this one here? What's the spacing on that? 6 millimeters. That should be fine. Well, just make these marks because I don't want to see them. I think we're about done here. I haven't actually started the front panel. I did start making one for the other board that I have. This is the start of that front panel, so it'll be something similar to this. And I'm hoping that I can get it printed as a PCB. I might even try getting an aluminum PCB printed because there's supposed to be a aluminum faceplate. They usually use a 2.5 millimeter aluminum as the faceplate, but these will be a 1.6 millimeter. Should be all right. I hope it'll be all right. This one had like a Ethernet here. I guess we could just get a start on it. Assuming those are okay. Don't need that one anymore. All right, looking at our spaces. Expecting it to be about 5 y axis. Well, actually, we need to go to the center, so 7.2 from the mounting hole. So 7.2 is there. Oh. That's not the mounting hole, is it? Okay. What's that? 12.7 from the edge of the board. And I'm pretty sure the edge of the board is going to be accurate, which would put it at 12.7 right there. 0.7. Okay, so that would be the LEDs 20.9. 20.9 is about there. That's probably too much, isn't it? Yeah. The thing I actually want to test is that it's going to be raised above the board a bit, but from the bottom of the board, center point is 16 and 34. Okay. 16. .2. Still a little higher. A millimeter higher. Still a little more. I'm sure there's a better way to do this. I kind of just want to see by rough what it's going to look like. I'm just going to leave it at that for now. actually. I need 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, they're not in the exact right position, but I just wanted to see that, like, I could do that to handle the USB. The keep out is 10 millimeters. And these are 9 millimeters. With the do that. I'm gonna make them 11. 3 millimeters high, make them 5. Oh, I need to copy that to here. 5. There we go. 11 and 5, 11 and 5. It should give a nice gap for the USB. I'll clean this up later, but that's basically it. So that's the board, and that's the front panel that'll be in front of the board. There's some metal brackets that connect from the mounting hole to the front panel. And this is the mounting hole on the front panel. So the mounting hole on the board is like right there. That's about it. I'll probably do some more cleanup on this board just before I end up ordering it. Probably will order it fairly soon, and then I'll do a stream of building it, but it'll probably be sometime in December. I'm taking time off work for Christmas, so I'll be building the board at that point. I doubt I will build it before then, but I also I'm planning on ordering a compact flash card that somebody else designed, and I'll build my own copy of that. And then I need to develop a separate memory card. The ultimate goal here is to have multiple CPU cards in the system, and then have them able to coordinate, able to do multitasking together, which will require some common memory, some common RAM. So the RAM on this board, these 2 chips here, are just for the purpose of working memory. You don't have to access the bus to use that memory, but there'll be global shared memory that would be on another card that all of these CPU cards would have access to. So at some point I'll need to design that board. I was kind of thinking of doing it after Christmas, but I might start on it before then, because I don't have anything to do between now and my Christmas break. So yeah, join maybe next weekend. I'll start in on the memory card if I feel like it. If you would like to join, then I would love to have you join. Thank you for tuning in today. I'm glad we got this all done. it's all ready to be printed, or almost all ready to be printed. I hope you enjoyed. If you'd like to see it later, I will be posting this stream onto YouTube as well. So, yeah. Thank you, and have a lovely Sunday evening if you are on the West Coast. Bye.